I have two vectors that look like this that I want to add together. That's not too hard, right? All I have to do is draw a resultant vector which goes from start to finish. Unlike the two vectors that I'm adding, which are always drawn front to back, my resultant vector goes start to finish. I can label in my theta, my angle here, drawn at the start of the vector diagram, label R, and then use the Pythagorean theorem in the inverse tan function to find the direction and the magnitude of that vector. In other words, to find the sum of those vectors. What if I have a vector diagram, though, that looks something like this? Instead of being 10 meters down and 15 meters straight across, what if it's 10 meters down and 15 meters up like this? That angle is measured relative to what, first of all? Which axis? North, south, east, or west? Where is it measured from? It's measured from the east, and it goes north from the east. So we're going to say that that would be 15 meters at 30 degrees north of east. How can I add those two vectors together if I have a vector that's 15 meters north at 30 degrees north of east? What do I got to do? What are the 5 words that should come to your mind right now? Even though it is early Wednesday morning, what are the 5 words that should automatically come to your mind? I don't like funny angles. So what we're going to do with this is take that funny angle off to the side and get rid of it. We got 15 meters. We got an angle of 30 degrees. And we have an x component to that 30 degrees, and we have a y component to that 30 degrees. Why exactly am I putting the x and y component where I am as opposed to right here? The values would be the same, right? So why am I putting them right here around this triangle? I want it around the angle. I want the angle to be inside that triangle. Might not seem like a big deal, but it is. All right, let's find the x component. Which side of the triangle is the x component here? It's the adjacent side. So if we think about sine, so, cosine, ka, tan, oa, so, ka, toa, which trig function am I going to use to find the adjacent side? I'm going to use the cosine function. Cosine 30 degrees is equal to adjacent over hypotenuse. 15 times cosine 30, I believe, is 12.99. And then, of course, we're going to use the sine function for the y component because it's the opposite side. Sine 30 degrees is equal to opposite over hypotenuse. Y ends up being equal to 7.5 meters. So I like to square that off just to set it aside from the rest of the question. And then let's redraw this. For those of you who are using a pen, you might need to physically redraw the picture. If you're using a pencil, you might be able to erase that vector and then just draw it in. So what do we got here? We got 12.99 this way. And we have 7.5 this way. My resultant vector will be drawn from start to finish. It's going to look like this. Now it's just like those other problems that we solved prior to yesterday, the ones that we solved on our quiz yesterday. X and Y components, right? What's the X component of the first one? 0 and negative 10. 12.99 and 0. 0 and 7.5. So we add those up, do the Pythagorean theorem, do the inverse tan function, and we're done. Like dinner. Got it? Not bad? All right, we had 3 questions on our worksheet that I want to take a look at here. I definitely want to take a look at question number 16. Are we okay with the other ones, or would you like to go over one or both of the other ones as well? If you're okay with number 16, you're probably okay with the rest of them. But if you're struggling with this, you know, if 2 or 3 of these questions, maybe you want to go over a couple of them just as practice here. Anybody for one besides number 16? 15? Okay, 15 and 16 it is. Question number 15, we've got 3 vectors. This should be 5.0, 8.0, and 5.0 meters. A little hard to see the decimal places there. We've got one funny angle, so we're going to take that off to the side and redraw it here. It's 5 meters. I've got 30 degrees labeled right here. So let's draw my X and Y components like this. Here's x to the left. Here's y down. We know to draw x to the left and y down because the vector 5 meters ends up below and to the left of where it started. X is the, Jonah, is that the opposite side or the adjacent side there, x? Good, so we're going to use the cosine function. Cosine 30 degrees is equal to adjacent over hypotenuse. And we're going to say sine 30 degrees is equal to opposite over hypotenuse. Box that off to the side there. And now let's replace the 5 meters with 4.33 and 2. Yeah, right. Yeah, you're right. 2.5 down and 4.33 to the left. There's no reason why I had to draw the y component first this time, but why did I draw it first? Yeah, it's a little less awkward if I draw the y component first this time. If I draw the 4.33 first, then it kind of goes back on this one, right? And then it just gets a little cluttered. So it doesn't really matter if you can keep it straight. It doesn't really matter what order you draw them in. All right, let's do x components and y components, and we'll be done. The x component of the first one is 0. The y component of the first one is -5. The x component of the second one is, it's 8, positive 8. The y component is 0. And the third one, okay, whether you decide to combine these two green vectors as the third one or just keep it as two separate vectors, vector 3 and vector 4. Nick, what's the x component of the third one going to be? Okay, if you're going with this, we could say 0, and the y component would be, we'll say -2.5 because it's down. Okay, and other Nick, if we're doing it that way, then what's the x component of the fourth one? We're going to say -4.33, right? And the y component would be 0. Now, what I usually do is end up combining these, right? I just say for the third one, the x component would be -4.33 and the y component would be -2.5. But it doesn't really matter, okay, whatever works for us. Okay, we add these up. What do we get? 3.67. And what do we get for this one? -7.5. And we're going to combine these. 3.67 and 7.5 goes downwards here. My resultant vector is right here. Find the value of r, and theta is going to be drawn in position 1, 2, or 3, Nicole. 1, 2, or 3. 1. Right, always drawn at the start of the vector diagram. Good? Okay, r is going to be the square root of 3.67 squared plus 7.5 squared. Theta is going to be the inverse tan function of 7.5 over 3.67. What do we get for the value of r there? 8.3. And what's the value of theta? What is it? 64 degrees. That would be 64 degrees what of what? Where are we measuring it from? North, south, east, or west? Yeah, we're measuring it from the east. So if it's from the east, it's of the east. And where are we going from the east? South. South from east, or south of east, we'd say. Anybody do this? You get 8.3 at 26 degrees east of south. How would you get that answer? It's correct, by the way. How would you get that answer? Draw the triangle the other way. So instead of going 3.67 to the right and 7.5 down, we reverse the order of those. 7.5 down and 3.67 to the right. All right? Good? All right, let's take a look at the last question, which is question number 16. Here we have two funny angles. Got to keep this straight here. Off to the side, we've got a 60-degree angle right here. And that's 5.0 meters. Here's y. Here's x. We'll worry about the other one in a minute here. The x component is which side of the triangle, Shay, in this case? The x component? Yeah, it's the opposite side because it's not touching. So we're going to say sine 60 degrees is equal to opposite over hypotenuse. X ends up being equal to, I believe it's 4.33. And then we're going to say cosine 60 degrees is equal to, cosine 60 degrees is equal to adjacent over hypotenuse. And I think that's just 2.5. All right, there's one of my off to the sides. Let's replace this with 4.33 and 2.5. Okay, now let's do another off to the side thing here. This time we have 20 meters at 30 degrees here. Here's X, here's Y. Which side of the triangle is the X component this time, Jillian? Opposite, adjacent, or hypotenuse? Good. It's adjacent, so we're going to use the cosine function. Cosine 30 degrees is equal to adjacent over hypotenuse. That's 17.32. Sine 30 degrees is equal to opposite over hypotenuse. My other off to the side thing that is important but doesn't form the main part of the question. Let's draw this as 17.32, and this one is 10 meters. So those two vectors now, 20 meters and 5 meters, are both at angles of 30 degrees. We don't really care about those vectors anymore because we've replaced them with these nice green and blue vectors that are all on either the x-axis or the y-axis. So let's do our thing now. X components and y components. X component of the first one, -10. Y component, 0. Second one, 0 and -10. Third one, well, what's the x component of the third one there, the green vector? Good. And what's the y component? 0. Or, actually, if you separate them, then it would be 4.33 and 0. If we combine them, it would be 4.33 and 2.5. It doesn't really matter how you do it. What about the next one? The x component, Mary, of the blue one is 17.32, and the y component is 0, or you could say -10, right? 0 if you separate those two, or if you combine them like I usually do, we would make it -10. All right. What do we got here? 4.33, 17.32, 6.5, 21.65, 11.65. And this gives me negative 17.5. And now it's just a matter of Pythagorean theorem, right? Where do I draw my angle here? Position 1, 2, or 3? 1, 2, or 3. Polly? Position 2, always at the start, right? What do we end up getting for R? Who's got that? Alex? 21.02. We're going to round that to 2 digits, so we'll make it 21 meters. Good. Alex, you get the angle there as well? No? Who's got the angle? Thank you. Zach, 56 degrees. We said it's 56 degrees, what of what? Measure from north, south, east, or west. East. So we're going to make it south from east or south of east. You may do this and get 34 degrees east of south. Drawing the y on axis first and then the x-axis. Means exactly the same thing, right?